Welcome to all of you. I am Gokul Raja, Assistant Professor at Sri Muthukumaran Institution of Technology. Today we are going to discuss the subject metrology and measurements. Its subject code is ME3592. These are all the course outcomes. After completing this course, you will be able to understand the concept of metrology and measurements, applications of linear and angular measurements, tolerance analysis for industrial application, surface metrology, and measurements for quality control in manufacturing sectors. These are all the course content. Introduction to Metrology and Measurements, Units and Standards of Measurements, Linear Measuring Instrument and Angular Measuring Instrument. First topic, Introduction to Metrology and Measurements. Dear students, first let us understand this subject in simple words. Metrology and measurements is a basic and important subject in engineering. It mainly deals with measuring things correctly by using different tools. We can ensure the accuracy, precision in measurements. What is meant by metrology? Metrology means science of measurements. And what is meant by measurements? Measurement means determine the physical quantities by using standard instruments and methods. Unit of measurements. A unit of measurement is a defined quantity used as a standard for measuring physical quantities. The unit of length is meter, the unit of mass is kilogram, the unit of time is second. Why need for units? Because to ensure the uniformity in measurements, to allow the comparison of result, and to maintain the accuracy and consistency in engineering applications. These are all the SI units. What is meant by SI units? SI stands for System International Units. These are all the applications of metrology and measurements in manufacturing sectors to ensure the product meet dimensional and quality standards. In automotive industries, used for precise measurements of components like engine parts and gears. See, this is the feeler gauge. By using this feeler gauge, you can easily check the piston ring side clearance. There are different thickness available in this feeler gauge. By using this feeler gauge, you can easily find out the side clearance in piston rings. Second one, dial gauge. By using this dial gauge, you can easily find out the surfaceness of the flywheel and gear surfaceness. Next topic, linear and angular measurements. Linear measurements and angular measurements are two fundamental types of measurements used in engineering, construction, and everyday applications. First one, linear measurements. Linear measurement means measuring the straight line distance between 2 points. It can horizontal line or otherwise vertical line. You can easily find out the length or distance between 2 points in straight line manner. That is called linear measurements. These are all the common tools: scale, vernier caliper, micrometer, comparator, telescopic gauge. By using these tools, we can accurately measure linear dimensions. By using these tools, we can easily measure linear dimensions. What are the applications? Measuring dimensions of object in construction work, in manufacturing sectors. Second one, angular measurements. Angular measurements refers to measuring the angle between two lines or surface that intersect to each other. Its common unit is degree or radian. The common tools used in angular measurement: First one protector, second one angle gauge, third one bevel protector, fourth one sign bar. By using these tools, we can accurately measure angular dimensions. There are various applications in angular measurements. First one, engineering drawing and design, surveying land angles, navigation, machinery setups like tool angles, gear alignments. These are all the applications of angular measurements. First one, linear measurements. The first topic is dial gauge. See, this is the dial gauge. By using this dial gauge, you can easily find out the error in tools, and also you can easily find out the flat surface of the workpiece. If any error occurs in this flat surface, the needle point will oscillate. If needle point did not oscillate means its surfaceness is good. If needle points oscillate means if surfaceness is not good. Which surfaceness is not good means it can indicate that place. Okay, so this is the dial indicator. So the dial gauge works on the rank and pinion mechanism. See, this is the rank and pinion mechanism. That's why this is the main working principle of dial gauge. To determine the error in geometrical forms, its principle is rank and pinion mechanism. It's used to compare the workpiece against the masterpiece. Okay, this is the dial gauge. It's one of the tool to measure the linear dimensions. Second one, telescopic gauge. See, this is the telescopic gauge in different size. By using this telescopic gauge, you can easily find out the internal diameter of the hole. For example, you can easily find out the piston cylinder bore. So you can fix this place. You can oscillate from top to bottom. If any places occur in error, it can easily indicate that place. Okay, if any gaps here available, that that is the error spot. After taking that reading, you can finally check with the micrometer. By using this micrometer, you can easily find out the reading. So compare the telescopic arms and insert the gauge into the bore. Then tilt and move the gauge side to side. Then only you can easily find out the error spot. Then only you can easily find out the error spot. Then finally you can check in micrometer reading. Then then you can easily find out the error spot. Next one, vernier caliper. Vernier caliper is a precious instrument that can use it to measure the internal and external distance accurately. That means you can easily measure the outer dimensions or inside dimensions or depth. By using this vernier caliper, you can easily find out these three dimensions. For example, you can find out the inner diameter of the pipe by using internal dimensions. You can easily find out the internal diameter of the pipe. If you want to coin outer diameter, you can easily find out by using the vernier caliper. See, this is the vernier caliper. This is the internal measurement place. You can fix the pipe here. You can fix the pipe here. You can easily find out the internal diameter of the pipe. And also you can fix the coin here. You can easily find out the coin diameter. If you need to check the depth, you can easily find out this place. You can insert these key places into the cylinder bore. You can easily find out the depth of the places. Next one, micrometer. Micrometer measurements refers to the process of measuring small dimensions with high precision using a tool called micrometer. It's commonly used in mechanical engineering, machinings, and metalworkings to ensure the thickness, diameter, or length of small object. It's mainly used for thickness. If you want to find out the thickness of the wire by using this micrometer, you can easily find out the thickness of that wire. See, this is the digital micrometer. This is the normal micrometer. By using this micrometer, you can easily find out the thread thickness. Next topic, angular measurement. Angular measurement, first one, sine bar. By using this sine bar tool, you can easily measure angular dimensions. See, this is the sine bar. This is the dial gauge. This is the slip ring. See, these are all the slip gauge. These are all the slip gauge. There are different sizes are available and different thickness are available in this slip gauge. You can fix the slip gauge in this place from layer by layer and then support the sine bar section from one place to another place. See, a sine bar has a two cylindrical roller at a fixed distance L. See, this is the length from this place to this place. This is the length of the sine bar and this is the height of the sine bar and this is the dial gauge. If you can move from this place to this place, if any variations occurs in this needle, the error will occur in that part. You can add or remove from slip gauge in this place. If the dial gauge is not oscillate, the reading is correct. Then you can measure the height or you can measure the angle. Okay. By using this trigonometry relation, you can easily find out the angles. Sin theta is equal to height by length. That means what is meant by angle of one object. So you can easily find out the angles using these formulas. So L means length, H means slip gauge height. Then theta means this is the angle. This is the theta angle. Then you can easily find out the angle of these components. This is the components. You can easily find out the angle of these components. Theta is the angle to be measured and H is the height difference between the two ends of the sine bar and L is the distance between the center of sine bar cylindrical surface as shown in the figure. For example, take one problem. A sine bar of 100 mm is used to measure an angle of 30 degree. The height of the roller above the other is. So here the length is given and then angle is given. What we ask, height is asked. So length is 100 mm. The sine bar length is 100 mm. The sine bar length is 100 mm. This is the center to center. This is the length. And this is the angle. This is the angle. Length is also given and the angle is also given. What is the height? What is the height? Height is asked. So what is the formula? Sin theta is equal to h by L. By using this formula, you can easily find out the height. So sin 30. Sin 30 means in trigonometry, sin 30 value is 1 by 2. Then h by 100. 100 means length value. Then 1 2 is to 52 are 100. Therefore, height is 50 mm. If any one data missing means you can easily find out by using this formula. Next one, vernier bevel protector. It's one of the tool. It can easily measure angular dimension. See, this is the components This is the components. By using this vernier bevel protector, you can easily find out the angle of these components. I hope this session will helpful for you to understand the subject clearly and practically. Thank you.